Nathan Glover, how are you?
I am very good, Mike. How are you?
I'm very good, thank you. Now, this is a couple of days before Christmas, and if it's okay with you, I'll probably put this out just after Christmas. So,
Yep.
that being said, how was your Christmas?
My Christmas, I think it was really good. I think I got everything that I wanted.
Excellent. Everything you
I
deserved.
think we had everything I deserve, yes, which could be nothing depending how this year went. But yes, how
Excellent.
was your Christmas?
Oh, no, it was amazing. Obviously, having to cope now with the extra lockdown is difficult, but we'll deal with that, whatever it is. It's just
Ah, yes, you're Sydney, yes?
no. So
Sydney?
so we're
No.
Brisbane, and obviously post Christmas, I'm now no longer allowed to leave my room. So, yeah,
Yep.
yeah, just dealing with that. Um, hey, I wanted to reach out to you specifically because of IoT. That might not surprise you, um, largely because I told you that already on Slack. Um, I think that I think that not enough people know enough about AWS IoT. It just it appears to me that it's maybe a little bit too complex, and so people just like dip into it a little bit and then just leave it. So I'd like to talk to you about that, and I would like you to help me understand it a bit more if I'm being blunt. I also want to talk to you about reInvent Part 2 Extended and your thoughts on that too, because obviously you've got some skin in the game with that, as I understand it.
Yes, yeah.
So yeah,
So where to start, I guess.
yeah, just go and I'll sit back. So no, I'll tell you a little bit about what I know, and then maybe that'll sort of help everybody understand the lack of my knowledge, and you can fill in the details. Maybe that. I understand that. I mean, from my point of view, I see IoT as in the service suite inside of AWS to include a couple of main things: Greengrass, which helps us to be able to deploy stuff to stuff. And so for someone in my position, that seems almost entirely deploying a Lambda function to a Raspberry Pi. I'm sure it's done at bigger scale and with more fancy equipment than that. And then also MQTT, so like this really lightweight messaging protocol, which is supported inside it with a bus, I think, or whatever the terminology is, inside of AWS. And so messages from devices that are deployed on Greengrass and potentially others can all just sort of commingle on there, and you can connect that up with other things. My setup here in this house, if I may, I've got two Greengrass Raspberry Pis, one upstairs, one downstairs. It's got they've got LED arrays on them, and when I come into this room, there's a little senses that I'm here. It sends MQTT messages to a broker that I've got set on my internal network, spits out to those devices to turn a light on so that people can see that I'm in the room and where I am. And when I record, like I am now, I have a button that I can make them turn red. But that's as far as
Oh,
I've got. And the thing for me is that these devices, these Raspberry Pis, they're fairly capable devices. And one major gap I have is, how do I connect in lower power devices that don't have as much crypto smarts to be able to deal with everything that seems to be necessary to get into that ecosystem. And on top of all
yep.
that, this package arrived today, and you can tell me more about that as well.
You got yours. Wow.
Oh,
Okay.
no,
You
I was
beat me.
hoping you'd have it already. Okay, you,
I
all
don't
right.
have mine yet.
Oh no, I'll have to do an
So I
unbox.
guess
All right.
we'll
So,
start at the beginning.
so be nice. How did I do? Now, then fill me in on all the gaps.
So you've already done everything. Like you've already got this stuff working in production. It sounds like you've learned a lot, which is good. But I think the way you've summarized it's really good. The way I see AWS IoT, like core, and that's what it is it's just MQTT broker. Like you're just pub sub sending messages and receiving messages from devices. Like at its core, that's really what AWS IoT is. But the entire suite of tools extends a lot more now to things like device management, fleet management, fleet deployments. So you might have 1,000 devices out in the field. How do you manage the deployments to all those devices? So there are a few sort of sub-services within AWS IoT that cover that kind of thing with fleet management. And Greengrass itself now also has its own mechanisms for deploying out to fleets as well. Because one of the biggest announcements this reInvent was Greengrass version 2, which is kind of a completely re-architected Greengrass to solve a lot of problems that people were having with Greengrass 1.
Yeah, okay. So can I
So
ask,
for me,
Greengrass, well, Greengrass versus AWS IoT, is one inside the other? What? There, that's the question.
Yep, pretty much. So you've got your IoT, you've got this concept of things, and all the thing is a device with a certificate that's able to talk to AWS. Greengrass sits on top of IoT Core. So Greengrass itself is actually just a little binary that runs on your device and orchestrates a bunch of different messages and rules on IoT Core to manage that device using AWS IoT. So under the hood, Greengrass uses AWS IoT, just PubSub to communicate back to the cloud. So you usually just provide the Greengrass device enough permissions to talk to AWS IoT, and it's able to do what it needs to do. But yeah, in reality, everything's just built on PubSub. That's pretty much how the whole service works, with a bunch of bells and whistles.
So if I have a Raspberry Pi and I feel it's so inclined, I can just connect into it, deploy the IoT Core libraries, ignore Greengrass. I can just do the IoT Core libraries and start to communicate with the MQTT brokers using certificates and the like, which are issued to me through, through the console or something more sophisticated.
Pretty much, yeah. And in fact, I've actually talked to some companies that they could have gone down the route of using Greengrass, but their problem just wasn't complicated enough to warrant it. So a lot of the times they'd start with Greengrass for prototyping, but then they'd realize, oh, we don't really need to manage all of this. In fact, it's a bit of an overhead for us to do this. So let's just go back to using IoT Core, a little bit of code, and maybe some IoT rules to do all deployments. And that's actually worked quite well for them. So it's interesting to see that Greengrass is sort of a good platform to start with, because it gets you in there quickly, gets you in there with some quick wins and understanding, and like, oh, cool, I can do all these amazing things. And then you start to scope things back, which I found really interesting, at least.
Yeah, absolutely. So, and that's a real key point for me there. So, because yeah, I started with Greengrass because that's where a lot of the tutorials will point you, especially if you're dealing with the kind of, Raspberry Pis. And so then I sort of felt like, well, that's what you do. This is really heavyweight. And all I want to do, and I think there's a change on this front, but all I want to do is put a function of code on this device that sat right next to me. Yet I'm having to go through all of these steps to do it. And it feels really hard.
Yes.
So what you're saying is that all of those steps are great if I'm then going to manage 1,000 Raspberry Pis that I'm not physically touching. If all I wanted to do was what I've just described, then easier ways.
It really included a lot of bloat, and that's actually good transition onto Greengrass 2, and why that sort of changed things up a lot, because they sort of listened to customers and they worked out that, okay, not every customer needs all these bells and whistles, so let's allow them to, let's rebuild this entire system to use components. So they have a new system where there's components and recipes, and the idea is when you run Greengrass, because now Greengrass is just a Java binary, you run it, it automatically connects itself to your AWS IoT for you. So you provide it some certs to do that. And then you can go ahead and add components as you see fit. So you don't immediately have to deal with all this stuff being installed on the Raspberry Pi or whatever device you're using out of the box. You instead say, hey, I just want to be able to manage a Lambda on this. That's all I want to do. So just put that component onto it and deploy it. So from that perspective, it's a lot better because it's a lot more lightweight and less overhead, less management for you.
Sure. So just give me an idea of what those components are. So running Lambda is one component, talking to MQTT is another component, or is that an underlying thing?
I think it's underlying. So your components have similar, I don't want to go on a tangent, but you basically, when you're defining your component, you tell it what it's able to do, like its capabilities. So there's things like RBAC, role-based access, You're allowed to talk to MQTT, for example. So there's all these different rules you can supply to a component, and one of those is to be able to talk to publish and subscribe from MQTT. Yes. Yeah. So there are other components. There's ones for secrets management. There's ones for token, so session token management as well, which is kind of cool. So it allows you all your components to go to one centralized source for AWS session tokens.
Right.
So if it needs to do something on AWS, it can go to the token authorizer, get its codes it needs, and then do what it needs to do. There's things for like being able to talk to a serial stream on a device, things to talk to IoT analytics, and it's all kind of the way they've built it. The components are designed to be open, so anyone can build their own component, publish it to a public registry. Which is something I actually asked for about 6 months ago, and I wonder if they listened, maybe. But,
awesome. Have you got some,
finally you can contribute? I do, yeah. Like, you know, if you have a special camera, for example, this is not a camera, but this is just an example. Like maybe you have a camera that you want to write a component for. You could go out and write a component for this specific ESP32 cam, for example, and say, you know, if you deploy this component, it will automatically start receiving video from that feed and publishing it to KVS, for example, or Kinesis video streams.
Yeah.
So you could go and write a component for that, publish it to the public registry, and then people could download that, and anyone with that device could immediately start leveraging that. So
that'd be brilliant, because I have gone through the process myself of trying to, you know, of getting the I'm Raspberry Pi based here, as you can tell, because that's what I've got. I've had some of those ESP boards that you're talking about. They seem very finicky with the wrong voltage. They don't like the wrong voltage because they all go forever sleep if you give them the wrong type. But yeah, just setting one of those up to get the little camera and get it streaming to Kinesis video streams takes a long time the first time you do it, and it doesn't take any time at all the second time because you just don't bother doing it. But yeah,
exactly. And ultimately, you want to get to the point where you're writing as little code as possible. That's, from my perspective, the less code I write, the better it is, because it means, you know, I never need to manage that. It's just a component I deploy. So
absolutely. So does that answer then? So this componentized way of deployment, does that answer the lower powered processes, because you can literally turn the components off and just streamline it down to just what it's capable of doing?
Unfortunately, not necessarily. So Greengrass isn't supported on like embedded firmware, for example. You can't run Greengrass on one of these yet. Who knows what the future will hold. I suppose you could, if you had a Raspberry Pi that perhaps the old Greengrass wasn't running very well on it. Maybe the new Raspberry Pi would be running better because there's sort of less services to manage. But I'd say that doesn't ultimately solve that problem for you, unfortunately.
Okay. Well, so talking that ESP device then, how do we get that working with IoT, AWS IoT? Is it doable?
Yep. Yeah, so there's a few routes we could go down. I can talk to, for example, that EduKit that you just showed off, that magic package.
Right. Yes, I bought it because you said it was a good idea, and it looked shiny, and it was the only toy that I could see from reInvent. Right, I'll open it while you're...
So for example, there's
there's
that device. That's an ESP32, so Espresso.
It is based on that, 32. Isn't it? Yeah.
Yeah. So, and they're probably the world's most popular boards right now in terms of what hobbyists use. Potentially Arduino. Like they're pretty neck and neck. Espresso sort of owns and rules that landscape, especially because there's a lot of community builders out there who write firmware, write libraries. And traditionally, that's the most difficult part when you're dealing with embedded devices, because here's an example. In my hand right now, I've got like four different types of embedded microcontrollers.
Sure.
All of them are really similar, but at the same time, very different when you want to interact with them. Like you can't just write some code and it will immediately work for all of them. You need like a, there
you go.
Shiny.
We should do that. Clearly, we're going to be doing an unboxing here. It arrived in this box, which is quite enormous. Most of it is actually cardboard. And it's got
wow,
got these little two things in the top. So yeah,
very
sorry,
excited now.
didn't mean to derail what you were saying.
No, all good.
Okay.
So I suppose, yeah, when you're deploying for these, this is what I think the EduKit's trying to solve is AWS themselves are going to provide some sort of a hardware abstraction layer. So it's usually some software that handles the interaction between your code and the hardware for you. So they write all that middle layer, all the stuff to deal with registers and all that boring stuff that you've never wanted to do. They write all that. They just give you like a simple function. Say, if you want to turn this pin on, you use this function this way. And that's how Arduino became very popular, because that's what they did. They created a wiring framework that allowed you to talk to all these different variations. And I think the EduKit is probably going to be based on the same open source frameworks.
For sure. So small amounts of code that are compatible with AWS IoT that basically abstract your way to just doing arguably the fun stuff. So yeah, okay. So yeah, all right. So there it is. I mean, at this point here, it's going to look exactly like it's going to look on the website. I don't know if that's in focus, but
that looks great.
Has yeah. It doesn't look like it's like it doesn't look like you can disassemble it easily. Like it's got no, absolutely. It's got Allen key things in the back. So obviously you can, but it doesn't sort of like click apart. It's got the screen protector there, which just taken off. Yes. It looks like it's got like LED strips down the side. Like that, yes. So on the bottom, I think that's the bottom, it's got some ports on there, which are 4
So I reckon they'll have they must have some breakout stuff in the box with it, potentially. Potentially some extra wires. So
far, that's interesting. We have an Allen key. So obviously they are encouraging you to take it apart. And a USB type A to USB type C cable, which clearly is just to charge it. And that's it. That's it. So yeah, so it's got 1, 2, 3 ports by the looks of it on there. They're 4-pin irregular types of, I'm sure that's got a name, but I don't know what. And then on the bottom, I think
because that device is I think it's the M5 Go, it's the stack, so M5 Stack.
Yes.
So I think those ports are designed to click into the other hardware that particular manufacturer builds. So
it's also got 4 little pads on the bottom, and nice. They are labeled actually as positive, negative, and then 2 kinds of wave, like one which looks like a pulse, and the other one which looks like a half a pulse, if that makes sense.
Yep.
I don't know what that's about. I'm intrigued by these holes on the bottom. Clearly they would stack onto the thing. But what
I think more of their products are like Lego-y.
Well, that's funny you should mention Lego-y. Obviously, that is also my thing. So I have a box of Lego here because I mean, you need. This was not planned. I need to try and find. Here we go. Here's a.
Yes. We'll click on that.
Yes.
Oh, perfect.
It's Lego compatible. Look at that. Does there?
Well, there you go. You can build it straight on top of your projects then.
Yes. Interestingly, those like the 3 and the 3, they do not appear to be Lego compatible, but the 4 in the middle are. So that you could sort of build it onto a little tower or something. We'll have to do that. I don't know. Interesting.
I look forward to that.
Yes. The old touchscreen on the front. Right. I didn't mean to derail you with that, but it literally arrived, this morning, and I was like, I'm going to talk to Nathan. We're going to talk about what this will do. I'm sorry that yours hasn't arrived yet. I figured that yours would arrive on a very similar day.
I'm in Perth. It will always arrive a lot later.
Some point. So yes. Am I right with one of the things that I latched onto? I'm going to take this apart while we're talking. One of the things I latched onto was the other thing in that was announced. I think this is a Greengrass thing then, which was some support for debugging code running on a device that's not normally, and I'm wishing I hadn't said that now because you're looking confused. Have I said something that doesn't make, I read it.
I might.
I read it and I thought to myself, that sounds like it tackles the problem I had, which is that you deploy code to the Raspberry Pi, it takes forever to get there, and then it's not working, and it's really hard to be able to get any debug back to figure out why.
Yes, so there is like a new debug framework for, I think it's a way of mocking signals or mocking messages from basically from an MQTT broker. Personally, I haven't tried it out yet, but I know what you're talking about. There is it's like a new, like a way to test messages being sent and received. Because right now you would have to sort of, to mock that kind of information, you'd need to set up your own broker or potentially have like a staging account in AWS IoT to produce messages.
Yeah, sure. Yeah, okay. Yeah, so yeah, you would have to duplicate everything. Oh, right, there you go. So I've just taken it apart. You're welcome. So in the base, there is a small LiPo battery by the looks of it.
LiPo, yeah, cool.
LiPo. So when you don't talk to people about these things, you just read it and you call it a LiPo battery.
Oh no, it could be LiPo. Like,
no, it's fine.
No, it could be LiPo. I also don't talk to people enough about it.
So 3.7 volts. Obviously, that's supplying the voltage, which means that hopefully I won't kill this one, because I believe it's based on the same chip, right, to the ones I usually kill. Yeah, and it's got like a whole row of pins there, which obviously as itself to a daughter board, I guess, to the main board. There's not a lot that is going to come out in this webcam, I'm sure, but there's just the circuit board under there. Cool. There's no noticeable, I'm doing that so you've got the light on it. It's got a SD card slot in the side. Some kind of, don't know what that is, like maybe that's an aerial or something. Yeah, and just a bunch of chips with, my eyesight's not going to tell me what they say. There's some magnifying glass is required to read that.
The whole point of this box is that you shouldn't need to open it, which is the the selling point.
And I wouldn't have done, but they supplied an Allen key with it, so I figured
that
was permission.
You can't do that.
That was permission to open it up. I suppose that's to replace the battery, maybe, if something goes wrong with that, or if oh right. And now, so the ports which we were talking about before, which are on the bottom, which are actually labeled port C and port D, on the inside of the lid, they're actually labeled as
UART.
One of them is a UART, so port C is a UART, and port B is GPIO.
Okay. Yep.
So it's got ground 5 volts, and then 26 and 36, which presumably the IO pins that which that talks to, and then the other one's just a UART. Yeah. And there's no. Yeah, there's nothing. Oh, the other port on it, which is a red port on the side, has the same symbols on it that the pads do that are on the bottom. So different way of stack extending it, I suppose. And yeah, you just have to be a little bit careful, because when you took the screws out, when you're taking it apart, you're obviously unplugging all those pins from the headers on the board. So
you could bend them.
Oh, I would excel at doing that. So especially when I didn't know that that's what was there, and I was like, why is it not coming off? So yeah, there you go. Let's try and put that back in. Looks like it's got some LEDs in there and stuff as well. So I will have to doesn't quite go to, oh, there we go. It's going together snugly now. Fingers crossed. It's okay. We have another one.
It should still work.
Everything goes wrong. I'm sure that with Allen key supplied, you couldn't void, it couldn't be a warranty voiding thing, because the Allen key is supplied. There you go. So I'm going to have that. Excellent. I did not expect it to be Lego compatible. Very super excited by that. So we'll have to build something with that. Have you got anything in mind?
Once I get mine, I'll play. I'm not sure. So I did my recent cat feeder, which was
Yes.
like a Raspberry Pi running Greengrass 2, and it basically opens and closes the cat feeder when it's turned on.
Yes. So
I was thinking,
we need to talk more about this, and you need to tell us more about this. And I interrupted you, but so running Greengrass 2, what triggers it to open and close? Is it a timer based thing, or?
So at the moment it's me sending a message to it to tell it to open. So I haven't built any extra compatibility around that. But yeah, sure, you could write it as a timer.
Yeah. Well, you could do the timer in the cloud, right? You could have a Lambda function running off EventBridge that just does that really quite easily.
There you go. You've just solved my problem for me.
Yes. I was just
the great part about living in AWS land is everything's the way you normally think about building these things is how I build this now. So
everything's like
that's silly little project that the cats actually hate because it makes a lot of noise when it goes off. But...
Well, so the mechanics of that are non-trivial, I would suggest, because cat food's not it's not I'm imagining when that door comes down, there are challenges.
It's not smooth.
Yeah.
Yeah. It's sort of like, and it sort of like bends out a bit, but it does work. It's just not very pretty.
Sure.
It's definitely a good prototype.
Yeah, we need to put some more horsepower in there so it can it can tell the cat food that it's the boss. But
problem is if the cat has its head there, then there's a lot of risk,
Oh, it's a paw in there. Yeah, that's true. Ooh. We need some more sensors built into it to see what's going on. Wow.
Protect the cat.
Yes. It's all about the cat. Is that the centerpiece for what your presentation in January?
So in January, it's actually not, it's sort of IoT related, but it's Alexa gadgets. So it's controlling this via Alexa as well.
Nice.
So I guess I use this as my base foundation for all my IoT projects. It's easy for people to understand, oh, it's a cat feeder. And so my presentation in January is on basically controlling that with Alexa, which is telling her to open and close the cat feeder, which is fun. Absolutely. So if you want to check that out.
I do. Well, do we have a link to it yet?
It's not yet, but it's the COM201. So it's COM201.
We'll put that string of text in the description so that people can at least use that and try and find it. How's your reInvent been? How was your reInvent prior to Christmas or whenever we are now live?
Mine was very, very interesting because the first 2 weeks, nothing IoT related was really released. It was only until that last week. And that's when Greengrass 2 hit for me was huge. Like I have a lot of customers who have been waiting for that. Things like the new IoT core for LoRaWAN, which is sort of a new service to basically install a managed LoRaWAN gateway and have it managed by AWS. For me, that's huge. For one of our customers specifically, it's huge.
Right, okay. Well, I don't know what
so I can explain,
LoRaWAN is.
So LoRaWAN is a very sort of low frequency, long range communication. So we're talking 4 to 5 kilometers.
Okay.
It's actually what that new Sidewalk is based on. So.
Oh, is that the technology which uses people's? Excuse me, it's not muted. Hang on. Right, now it's muted. Alexa devices to share your internet out with other people.
Pretty much, yeah. So I'm pretty sure that's what they're using underneath to basically mesh together a bunch of devices. But we're talking 3 to 4 kilometers per device. And what companies like some of the mining companies in Perth will do is they'll stick one of these boards out there with LoRaWAN chip on them, which I do actually have around here. There we go, it's right in front of me. So they'll have like a LoRaWAN communicator attached to it, along with a antenna, and it's able to talk 4 to 5 kilometers. But the problem is you need a gateway to be able to talk for these to talk back to.
Yep.
Traditionally, a lot of these gateways are open source projects, pretty expensive things that you have to run yourself. It's like a server running somewhere. It's a bit of a pain. So this new service that they've announced is they basically got a bunch of the common manufacturers to say that their devices can be installed and registered with IoT Core for LoRaWAN. And then what AWS will do is take any information coming from that gateway and then forward it off to other cloud services for you. So it's just one less thing you have to manage yourself. It's a piece of hardware that you can with AWS. It's not something that general users will probably use. Like, I don't think you and me really need a LoRaWAN gateway, maybe, but for companies,
doesn't mean I don't want one.
Exactly. But it's something that, yeah, once a lot of these big mining companies will probably install a couple and have them managed, and it's just, you know, why manage it if AWS will manage it for you?
Yeah, sure. So this is very small, low power devices, or maybe low power-ish devices. I suppose if they're going to transmit that far, you've still got to transmit that far.
Extremely low power.
Oh, okay.
It's surprisingly so. LoRa is low. It's low power, long range. So we're talking. Some devices can stay out in the field for 2 years on a LiPo battery like what you've got, and every like minute or every hour they automatically wake up and then maybe transmit some data.
Right.
So this particular, the LoRa is used very widely now for the specific reason of low power.
Yeah, sure.
Obviously, it's only like for a very small amount of data that it can send. So
yeah, sure.
send like a video
but
stream,
I can imagine a lot of applications for this, like you said, mining applications, agricultural applications, you know, levels in water tanks and the far side of a property and the rest of it. And if they're meshing together, are they meshing together, you said? So you can
mesh together.
Right.
So there are some devices that people, I've actually got a few on order, but you can like attach them to yourself and go out in the bush. And the idea is that if there's a bunch of people with these devices, they'll mesh together and create like a network. So there's some cool survival and some uses in like, I don't know if there's national global issues like, I don't know, earthquakes. They can use them to communicate back and forward without needing proper infrastructure. So.
I like you went straight to the altruistic. I was thinking some kind of survival games kind of thing, like you could a laser tag on steroids where everybody's got their own little devices on.
That does sound cool.
Not quite so altruistic. Yeah, okay. And so this announcement, I'm just sort of making sure I understand it. So does this ultimately enable these devices to be on the AWS network, but like through these gateway devices now, they basically will now talk directly into IoT MQTT?
To put simply, yeah, it's just a managed way of doing something that before it was annoying and hard. Now it's easy because you can just go to one of the manufacturers AWS says to, buy their thing and attach it to the cloud.
So this is something that I had only just become properly aware of, is that there is an entire page with pages and pages of devices which AWS don't make, but they certify somehow. Like, so for example, Kinesis video cameras and a whole bunch of other stuff. How long's that been there? I feel like it looks like it's been there for ages.
It's been around. Sorry, the dog's in the back.
That's right.
It's been there for a few years now. They've obviously had many devices prior to sorry, the dog has to be barking.
It is.
So a few years ago, they announced it.
Wants to know where its feeder is.
I know.
So yes, there is a big long list with lots of things that you can get to certified. And yeah, look, there's so many more things that we could talk about, and I feel like we could talk for hours and hours and hours. So we probably shouldn't, and maybe we should talk again at some point. I'd be interested as to just your thoughts on the AWS services which came out, which aren't necessarily IoT specifically, but like Monitron. Like Monitron is now commoditized IoT, right? It clearly would be that under the hood.
That for me is huge. Like, again, big companies buying these devices, installing them in the field instead of building and writing their own software. For me, that's huge. Hopefully we see its uptake.
Well, we'll have to wait and see how well it works. But thank you so much for making time to talk to me. I really do appreciate it. We'll look forward to your presentation in later on in January, either in January or later on. Depends when this video drops as to what makes sense for what I just said, but it's after Christmas. So yeah, looking forward to seeing that. And maybe we can connect back up again and continue to chat, because I've really enjoyed it.
Yeah, for sure. yeah, it's a lot of fun, and I think we should schedule something in again.
When you have received yours, and I do apologize.
When I've got mine, yes.
I didn't mean to troll you by look what I've got, but having said that, look what I got. Okay, I'll see you later, Nathan. Thank you so much, and I'll
catch you later.
talk to you again soon. Bye.
Catch you. Bye.